We'll begin our study of estimating population parameters with the proportion. And we want to, in the next few videos, find a method for using a sample proportion, which our notation will be p hat, to estimate the population parameter or population proportion. This is our parameter, this is our statistic. So we're using p hat to estimate p. There are three main ideas here. First, the sample proportion is the best point estimate for the population proportion. Best point estimate. And this goes back to the fact that it's an unbiased estimator, as we saw in a previous video. We can use a sample proportion to construct a confidence interval to estimate the true value of a population proportion. And third, we should know how to find the sample size necessary to estimate a population proportion. So once we learn how to estimate this, get this confidence interval estimate, we'll also talk about finding sample size. So at this point, as we talk about proportion, that's relatively new in our discussions. We haven't really talked about that statistic and that parameter as much. Let me make a note here that when we talk about a proportion, that's the same thing as a probability, which is the same thing as a percent, or we can change it to a percent, right? Okay, so when we talk about proportion, we can also talk about probability or percent. Let's look at an example to understand that a little better. Okay, so a poll was conducted to determine the proportion of Americans who own American-made automobiles. The result of the sample was the sample proportion was 0.57. So here are the ways we can conclude. We can say that the proportion of Americans who own American automobiles is 0.57. We can say the percent of Americans who own American automobiles is 57%. And we could also say that the probability of randomly selecting an American who drives an American automobile is 0.57, or owns American automobile. So again, that 0.57 can be, we can talk about it in these three different ways. And a problem statement may talk about percents, it may talk about proportion, or it may talk about probability. We just need to be aware of that. Okay. So, if we want to estimate a population proportion with just a single value, well, the best estimate is the sample proportion. That was that number one that we just said. This is called the point estimate. Point estimate, because it consists of a single value. If that's all you need is just one value to estimate that population parameter, well, we can use our estimate we get from taking a sample. However, using one value to represent p doesn't tell us how good that one value is. We don't know how accurate our estimate is. We've seen before that there's variability in sample results, sample proportions, sample means. Each time you take that sample, you won't get the exact same result. And so just using one value to represent p doesn't tell us how good that is. We really don't have a feel for accuracy. So to address this problem, statisticians have developed another type of estimate that we've already started talking about here, and that is the confidence interval estimate. And this is a range or an interval of values used to estimate the true value of a population parameter. Confidence interval estimate. Okay, so instead of having one value to represent our population parameter, whether it's the population mean or proportion, we will have a range of values, an interval, and we'll talk about how confident we are that the true population proportion or the true population mean lies within that confidence interval. So using a range rather than a point. If we only can use a point, or that's all we have, then we use p hat, the sample proportion. But better still, we create a confidence interval and we talk about the true population proportion being in that confidence interval. And you'll often see confidence interval abbreviated just capital C, capital I. So you may see me using that. You may see that in your textbook.